Greetings, everybody. Thank you for joining us for our final talk on discussing what it looks like between a campus and a data center core. Kind of what we looked at in the past was what our designs are today, why we're having issues with those, why they don't scale with what the needs of today are. We had Davis on to talk about the data center side and best practices, what we're looking to do there, and things we should take in consideration. And then this one will be focusing on the campus side. And so Davis isn't here for this one, it's just Jay and I. But we'll kind of summarize what we kind of talked about, why we have issues, and then spend the rest of the time looking at when we're looking at doing a campus design, what are things we need to take in consideration. And we'll also kind of talk about SDA too, since this is a new topic of trying to do some software-defined networking, software-defined access, things you want to take in consideration if you're going that route, and how you prepare for those. So start with anything you want to bring up as like a summary side, Jay, on kind of what we've had seen in the past, and then we'll dive into the architect stuff of today.
Yeah, I think when we're talking about software-defined networking, we talked a lot about ACI on the data center side. The campus LAN equivalent with Cisco for software-defined networking is SDA, software-defined access, which we won't take a deep dive into today. We'll talk about it a little bit. But there's definitely been a lot of changes on the campus LAN side, I think, from a hardware and speeds and feeds perspective in the last few years. So I'm excited to dig
Yep.
into it.
Yep, absolutely. All right, so we'll talk about, and the reason why this is important is that if you're designing for a new campus today, you do the underlay is important, which is the way that data is going to get processed through, even on the SDA SDN side, because then that's just over the top. So that one is a logical view, but the physical underlay still is very important on how that traffic is getting passed across. So we'll talk about how we kind of do the architect side. So if we're going like with the traditional three-tier of you have your core, your distribution, and access. I know back in the past with the 65s and 68s, we used to just put everything in one, and we would just use that as needed. Collapsed core, collapsed access, and needed in some of these spots, because you just had to get ports, and maybe you had an extra line card. But the reason why we want to separate this is each level is kind of doing its own function. So we'll start with the core, and the thing that we'll talk about too is kind of what, from today's perspective, you're looking at Cisco, where does that tie into those levels? So when we talk about core, we're talking about the new 9600 chassis that are coming out. If you still like the chassis model, if you already have a lot of upstream devices coming to it, or if you're able to break that off, you can look at those high-end SKUs on the 9500, the high performance SKUs for those 9500s to have a lot of throughput, because what we care about in the core is how much traffic are you able to get and get out quickly, because that's the whole point of it. The reason why it's at the core is it's got to go somewhere. And so you need it to be able to respond quickly, handle a lot of throughput. And that's what those 9600s and 95s do very well.
Yeah,
Which,
they're incredibly high bandwidth, right? Up to 400 gig now with some of the line cards, which is overkill for a lot of campus LANs, but still, we have to have the capability. Some folks definitely need it.
well, think
Um,
about how far we've had those 65 or 6800s. Like some of those are 7, 10 years that you want. If I'm buying this, I need it to last a long time. So you got to kind of think 100 gig might be a bit excessive today, but as we scale in the future, that's at least going to position you well to have that life cycle management of it.
it's good to have the flexibility, right? The other thing I like to point out, the three-tier model doesn't necessarily have to be dead. I mean, a lot of folks have moved to a campus LAN collapsed core, but there's still a spot for aggregation, I think, depending on fiber constraints and just good campus design based on where your fiber is laid out and whatnot. Sometimes it does make sense to have that kind of middle layer, the aggregation tier, where we just bring in a bunch of fiber from a bunch of closets, aggregate it into one place, and then send it up to the core. It depends on your campus layout, but
Yep.
the three tier isn't necessarily dead. But in those cases, we usually still see like the 9500s as aggregation switches, so they can fit in that role well. But you know, um, I think before when we were talking about tier three, like core has always been just high speed routing, right? We're just routing amongst different distribution layer switches, and that's still true today. But kind of the campus LAN moving forward, just like the data center side, we're moving to more and more layer three. So, it used to be your distribution layer would also house SVIs for your access layer, and you would trunk everything up and around, right? We're really working hard to decrease dependency on layer two technologies,
Yep.
especially spanning tree.
Yeah,
right?
exactly. The whole point, trying to get rid of it, or at least really minimize the impact that that's going to have with it. So that's where I've always, as I started getting more exposed to it, is the idea that I really want my core to really have a very simple, basic configuration, because that's not where I'm pushing a lot of policies anymore. Because usually that means you're trunking a lot of layer two up to that device. So you want it to be more of like just quickly in and out traffic, be able to handle that stuff quickly, and then you start pushing those policies down to the next level. And so that's kind of we'll kind of talk about the distribution level. And so this is where we'll kind of see 90, 95s mostly on this one. There are the SKUs on it. You could then, but if you had to, the 96 with the line cards to handle all that. It just depends on the needs of your environment with how much fiber is coming up. If you can do it with a 1U, you can. We'll also kind of talk about high availability, because we can do Stackwise virtual. That way, if you can dual home, take one device down for maintenance, bring it back up, do the other ones to minimize the outage. If something happens, we can still handle those processes. And same thing with the core. There's 96s. You'll do the Stackwise virtual on it to be able to have the high availability, because we can't be down. And so you still get the uptime that we need on those. But it just depends on how much connectivity you need. 48 is enough, or are you going to need 96 or more? So kind of just depends.
Yeah. I think an important distinction to make too is, Stackwise Virtual, great technology. We've had variations of it for quite a while, and it's great. If you're going to have two switches at an aggregation or core layer, and you need to do layer two from one switch to them, you can build a port channel between those two Stackwise connected switches. Um, we're kind of decreasing our dependency on technologies like Stackwise Virtual as well, though, as we start to move towards more of a layer three routed network. Because if I'm doing, OSPF or EIGRP up to each of those switches that are running layer three code, um, really all that can be layer three.
Yep.
So there's a lot of different variations there. But yeah, great call out. The 9500s, 9600s, lots of redundancy options. We can do field replaceable power supplies, in-service software upgrades.
Yeah, which
With
is amazing.
sharing.
Like, I don't
Yeah,
like coming from where it used to be, like a patch. I don't know what that is on a switch, and nowadays it's, oh, just apply this, and it's a not a whole reboot. Like that's really cool to me.
yeah, yeah, definitely. And it seems easy in some of our environments where we can get maintenance windows, but a lot of environments you can't do that.
Yeah.
Hospitals. So you need the ability to be able to patch your switches and routers and get them up to the latest code and out of those security vulnerabilities, but you don't want to take an outage. So
Nope.
those features are really important for that.
And then what we'll kind of mention just on the software defined side is when we're looking at the distribution, depending on what you're wanting to do with those, might require you to use the high performance ones, because we'll run into issues with some hardware has limitations on how much either virtual networks they can handle or how many hosts they can identify in those networks. So if it's one of those that you don't have a lot of devices connecting to, you can go maybe use one that doesn't need all those tables. But if you have a lot of access users or a lot of virtual networks you're trying to isolate, you've got to be aware of, all right, maybe I need to go with one that's got higher CPU, higher memory to be able to handle all the extra requests that come with it. So that's one of those, when you look at that distribution level, you got to think about, how am I going to use it? If you're just using it as layer three, maybe we don't need to look at doing the high performance ones. But if we're thinking we're going to maybe push policies at the distribution level, maybe this is where routing's happening for whatever reason, I don't have it on my access stack. You got to think then I probably need to allocate more resources to handle what I'm wanting it to do. So, and that's where, it just depends on your needs. If you can get by with 1U, we can do that. If you feel like you've got a lot of fiber coming up, that's when we can kind of look at the chassis models and go from there. And then once we get past with distribution, we go down to the access layer. A lot of options anymore on the access layer. Like, we've got 92s, we've got 93s, and then we've got fixed uplinks for both of those that you can use. We've got the Catalyst 1000s for little just small deployments for a spot that you don't want to run a lot of cables to. But this is where it also comes into play of what you're wanting to do with your network. This is where we would like to see routing happening at these devices so we can keep spanning tree away from the rest of the network. We apply the policies on those, and that's why you see these 93s as like super beasts that can just handle everything. They've got amazing compute, they got amazing CPU. You can put SSD in these devices to start running containers if you're trying to use like Thousand Eyes. Like if you could run that off that, I see the blog where like somebody used a 93 for Minecraft. So there's there's a lot of things we can do.
Yeah.
But like you said, the whole goal is push that down. So we're just this access layer is really kind of like, hey, this is your home for what we're taking care of these users, and then up is just availability, and then out to the rest of the world.
Yeah, the model has changed in network security, where it used to be we just put these firewalls in, route everything to these firewalls. But there's always so many considerations there as far as traffic hairpinning and you know not as much flexibility for the end users, right? Like the resources I get access on my wired network at my desk is different than what I get access on wireless based on the fact that I'm on different networks and I'm
Yep.
maybe hitting different firewalls. Anymore, we're trying to get away from that model, right? We're trying to get to routed access. We're trying to enforce policies at the access switch port or AP user based level to say it doesn't matter where Lance is sitting. I know this is Lance based on the authentication with his machine, whether it be his phone or his iPad or his MacBook. And we can set up different policies and rules for each, of course. But wherever he is, I want him to have the same user experience, right? And the example I always use is as network engineers, of course, we understand this, but you probably put management ACLs on your switches and routers today, right? It works fine when you're sitting at your desk. But if you remote in via VPN, what do you got to do? You're probably having to log into a jump box so you can log into the switches. If you're on wireless, what do you got to do? You probably got to go hit that jump box. It's just kind of painful. And that's one example, right? It's
Yeah.
one that affects us. But the businesses get affected the same way every day with their tools. Um, so yeah, we're just trying to push all that policy decision making closer and closer to that edge, closer and closer to those client devices to make for a better user experience and make management easier. We're
Yep.
not running around changing VLANs on switch ports all the time anymore, right?
And that's also where, I mean, it's easier to apply security at the host level rather than trying to pass that traffic around everywhere. So we have like Stealth Watch that we can put in on those to get that information directly at the endpoint level. It's just that idea that that's where everybody is. So it's easier to apply closest to person. And so that way, that's, but that's where it comes into play of what you're trying to do with your network. And so if you're only have a few maybe VLANs or virtual networks that you want to spin up, you can, it allocates depending on what resources. So you do gotta have to think long term because like you said, you want these things to last a long time of do I need to think about how many virtual networks if I ever go SDA, or is it just I can use fixed up links and kind of just tailor it to what I want. So each deployment's a little bit different, but those are a couple questions you need to ask yourself when you're looking at that layers. What do I want to do with it? Because we're doing much more than just connectivity and I'm trunking a VLAN down. It's the whole idea that I can put all these type of tools in my box that can handle what my users want to do. So
Yeah, absolutely. And that's one of the key differentiators. You touch on virtual networks. When we talk about 9200s versus 9300s, that's a big one there. 9200s, I think in the most restricted model, can only do up to 4 virtual networks. Almost any enterprise network, you're going to need more than that, right? Like
yep,
every different segment I want is going to be another VM. So, maybe finance is on one and IT is on another, and IoT hopefully is on its own. These are all
yeah,
really the IoT devices. But you can see it get out of control pretty quickly there. So yeah, that's usually one constraint. Some other technologies I like to talk about in the latest access layer models. Um, PoE, man, we have like every variety of PoE out there now, right? I
yep,
mean, pretty much everybody needs PoE. It's running your WAPs, it's running your IP phones, it's running your PoE cameras. Um, we have PoE Plus and UPoE now for those really high capacity devices. Um, MGig, that's another
yep,
technology we've seen taking off, especially on the wireless side as Wi-Fi 6 comes out. And our Wi-Fi clients start trying to pull down more and more data, the constraint quickly becomes the switch port.
yep,
If my Wi-Fi 6 WAP can do multiple gigabits at a time, my switch port feeding that WAP also needs to be able to do that. So,
yep,
MGig with newer cabling, we can run up to 10 gigabit potentially. So we see a lot of MGig, PoE, obviously on the access layer.
yeah.
And we have a variety of support for different models across 92, 93, and 9400s for that.
And then a lot of cool things you'll see, at least that I thought was really cool on the access layers when we're looking at 93s, 92s, is the ability to do 110 or 25 gig uplinks. And all that requires is a SFP change rather than going to a QSFP plus or whatever, like the slot changes. So you can, the same one that you're using for your 1 gig or your 10 gig, it's using the same SFP plus size. And when you're ready to upgrade those branches to 25, you don't have to do a massive change on your fiber. You're just connecting new SFPs to whatever is on your 93s up to your distribution or even directly to your core if you're doing the clap stuff. But so much more flexibility than, oh God, I got to replace a whole new module that's in my switch, and then I've also got to run new cable between these, and then I got to buy new ports, SFPs that go with it. So I thought that was really cool that we can do the 25s with the 10 to just, if you ever get close to it, then you added more resources to those. So I thought that was kind of cool too, as just an SFP change rather than a whole network module change.
Yeah, no,
But
that's a good point. So, Lance, let me get your hot take on something. How do you
okay.
feel about stack-based switching versus chassis-based? Want to sum that up for us?
Yeah, I my personal favorite is the stacking. I like the idea of having, the power stacking all in one, and then I can just take that out and do the switch if I need to do some type of replacement. I like being able to then allocate because I don't always know how many lines I'm going to need. So where if I start with 4 and then if I add 1 or 2 or all the way down to 8, I can do that. The chassis ones, I'm always a little scared because I don't know what happens in the future. So if I start with just a 4 line card and then suddenly they remodel and now I need to add more, like I just went past my chassis.
Yeah.
So that's
At
where
that
I've
point, you either have to add another chassis or replace the
yeah.
chassis with a model.
I find like closet wise, but if it's like very static, I think chassis is a great way because it's all in one thing. It's easy, supports on that. It's all in one spot, and especially now with high availability, with the way that you want with those chassis, you can do it. It's just, but it's really, I would say, personal preference. Or once again, we come down to if what the purpose of that is. So if you're trying to do a lot of SDA, those 94s are going to be perfect because they have the supervisor cards to handle all that. So you can do more on the software-defined access side. And then the 93s, if you pick one, you're kind of stuck with, let's say if I did 92 and I needed suddenly more virtual networks, then you're kind of like, oh man, I should have done 93 here. So you got to really think about the purpose you're using that floor or where you want to go, and kind of tailor in. What do you think?
So I'm kind of in the same boat as you. I tend to lean towards the stack-based arrangements. I think it's just because that's what I cut my teeth on.
Yeah,
But I
me
still
too.
see a lot of chassis-based deployments out there, especially for those environments where we have to have high availability, right?
Yep.
I need in-service software upgrades. So, with the 9400s and dual soups, you can do software upgrades. That's hitless. That's no hit to your network traffic, which is crucial for like our healthcare customers
Yeah.
and things along that sort. So, for those 24/7, 365 environments, I still see chassis get used quite a bit,
Yep.
but you do need to plan ahead. I mean, you're right. If you need 4 line cards today, you better put in a chassis for 7,
Yeah.
just in case.
Yep.
Um,
Well, you never
you
know
always
how
upgrade.
much. Yeah, or how much IoT is going to get added in too. Suddenly, like we do let's say we're doing a SAN that's got our cameras, but we're going to switch over to Meraki and we're going to plug those into our network and we're going to manage it. Well, those cameras, depending on the coverage, you just added 46, 96, 100 some cameras that need connectivity. And you look at your stack and you're like, well, I never thought I was going to have to plug in cameras, IoT, thermostats, almost anything. So it's one of those. Yeah, I always liked it so I could just add a switch. But like you said, if you're going with a chassis, just be aware that maybe you might want to have the allocation to add more if you get that route, um, and go from there. So, but
we're,
I
we
think
are
that.
seeing we're seeing a lot of scope creep on the IoT
Yep.
side. And I saw that in one of my previous roles where the facilities team had some IoT devices, but it was like 4 or 6 ports per switch, and then
Yep.
eventually I grew to 8, and then 12, and pretty
Yep.
soon you're taking up half of a 48 port switch, right? Where we used to have a 24 port switch without any issues. So definitely something else to keep in mind: cameras, thermostats, UPSs, I mean, you name it, right? And we're network connecting it.
Yep.
Doorbells, and I don't know
Yep.
what they'll think of next.
Yeah, exactly.
PoE
So
powered lighting, that's probably a thing somewhere, I'm
I've heard
sure.
that so electricians would like to plug into our switching because it's a much more reliable power source that if they can plug in, they would like to. And so I see that maybe lights to a closet or something are going to get homed in on that to where you're going to need PoE that's always up. Like you can't have, even though they maybe they're stuck on booting, but it's still giving PoE. And so that's some of the other cool things we do on the catalyst
Uh,
side. But that's a
that
whole
is
nother
another
different topic.
That is a good feature to bring up, though, is PoE
Yep.
fast start, right? So it
Yep.
used to be you had to wait 5 minutes for the switch to get booted, and then PoE to start. Now we start delivering PoE within seconds of that switch starting to boot. So by the time
Yep.
the switch gets booted up, the phone should be ready to start accepting network connections. So that's a great call
Yep.
out.
Yep. So all right, so we talked about the different ways to do your campus with the more traditional style, why you want to really put some thought into what you're wanting to do with those layers. Really try to push the routing for or your access layer down to the access. You don't want to try and trunk those VLANs around. You don't want spanning tree taken out. You don't want convergent times to take really long. So we'll kind of go now on the software-defined access, software-defined networking portion of using controllers and trying to manage that stuff to where that's kind of where the next step is for us. We want our networks to start doing things for us rather than just setting and forgetting. We want to be able to pull analytics from those. We want to be able to get health scores for devices. We want to be able to know when something doesn't look like this is normal traffic. So trying to make things have a purpose rather than just connectivity is kind of where what we're trying to get to with the SDN portion of it. And that's when you got to think about, all right, if I have if I'm going SDN, if I'm my core, how many users am I going to have to be in charge of, or how many devices am I going to see up there? We can start thinking about border nodes, control nodes, and we'll probably do an episode that just on SDN and how you design for it. But things you need to think about if you go that route is just what you'll see in your environment, and that's when you kind of run into, you could do 94s for stuff like that, but that's really where the 96 comes in because you can see so much of your environment. You got to start allocating, this guy is in charge of seeing all these devices, all my MAC addresses, and so it's based by like how many units you can see. And you got to plan that stuff out right, because if you expand over, suddenly you can't apply software defined access like you wanted to.
Yeah.
And that's where those 9300s come into play, because that's where you want to put your virtual networks, and that's where you're applying policies. That's where when people get plugged in, you're identified and you're pushed down your policy happening at the access, like the actual interface, which is totally amazing.
Yeah, I think in days of old, we thought of the access layer as kind of the dumbest switch in
Yeah.
the world. Like we're just going to trunk some VLANs down to it, and we'll make VLAN config changes as we need. It's going to deliver some PoE, and it's going to be 10, 100, 1,000, and we're done. We've really kind of changed the model on that. I mean, really now the
It's
access
almost
switch is
flipped.
more than
Like
need. Yeah,
you changed it. Yeah.
yeah, because I mean, and that makes sense because we should be authenticating based on users or devices connected, and instead of this legacy thinking of all my PCI information is going to live on VLAN 1000, right, or whatever. It doesn't make any sense to keep living in that model. It makes more work than you need, and it
Yep.
doesn't make for as good of a user experience.
Yep. And that's where we start talking about templates and trying to, best practices for those. That way, if you plug and play, we're not trying to run to a site to get the configuration set up. The idea of having a centralized management with your DNA center, or maybe DNC cloud in the future, that you want to be able to just plug a device and you just manage it through a template that's pushed down instead of CLI everywhere, OneNote pages, and then forgetting to copy and paste the correct section into your device. I've
Yeah,
never done that before, right? So,
it's zero touch provisioning, right? Like
yep.
if I'm going to go refresh my LAN, it sure is nice to be able to just go out, rack and stack the switches, have them pre-configured in DNA Center, and come right up on my network. Um, you know, I think I've made the joke before that that's how I got my start, right? As an intern, was we had
Yep.
like hundreds of access switches that needed to be configured and have the right software image put on them, and I sat there for a couple months and did that. Which I'm very grateful we didn't have DNA Center back then because I probably wouldn't have got my start in
Yeah, you
networking.
would have.
But
Well, you
yeah,
could have been the
nowadays,
intern creating the templates now. So there you go.
very good. I've been in way over my head at that point. But yeah, nowadays we can rely on DNA Center and other software packages to do that software image management, ensure all my switches have the right code on them, seamlessly work through upgrades and make
Yep.
sure the entire campus LAN is being upgraded at the appropriate time. As well as enforce those different config templates and make sure all those things are happening. We talked about it a lot on the DevNet side. When you manage a network of a dozen items and you need to go change the DNS server, that's pretty easy. When it becomes
Yep.
dozens and hundreds or thousands, and it's like, okay, we need a way to automate this.
Yep.
And DNA Center is certainly a way we can do that on the campus LAN side.
Yep. Yeah, it's one of those that the idea is to make our lives engineers easier and actually spend time thinking, enjoying the stuff we enjoy, which is solving problems that are coming up, innovating for, like having those visions and architecturally the stuff we enjoy, and not so much the day-to-day tasks of I got to go update something or I got to go see why this isn't working. We want to be able to use those devices to help our day-to-day. So that's kind of the idea with SDN, but that's where you got to think about those purposes again on those layers. And that's why you're seeing the access layer so powerful, because we're asking it to do so much. And then when you do that SDN, SDA, you're just thinking more of you have your overlay that's in charge of that then, and then you're just sending traffic through these devices. You're just sending up. But that's kind of the idea. You just got to think purposely of what you want to do with those areas.
Yeah, I commonly like to say that the transition to SDN is a transition of duties. Today we don't have to do a ton of design up front when we're talking about refreshing our campus LAN, but we do a lot of day two work once it's in, right?
Yep.
There's a lot of day-to-day troubleshooting and correlation between users and their issues and where they're actually at on the network and what's causing that. I see more of a shift on the software-defined networking side where we do a little bit more design and work up front to make sure all the right pieces of the puzzle are in there, but a lot less work on day two.
Yep.
So it's a little bit of a trade-off, but I think it makes our lives easier in the end for sure.
Yep. Absolutely. Well, I think that kind of covers the, just a high level view of what we're looking at when we think about the campus design. You still do want to separate your campus from your data center. There's different functions for what you want to do and different ways to manage those. And we'll hopefully we'll do a couple of videos, like sum up some software defined access and SDN, what that means, what it kind of looks like. Because it's hard to try and cram into a very short video, especially when we're just more architect than, purpose. So
we need an hour and a lot of whiteboards and
yeah.
slides to help cover
Yes.
parts and pieces there. But yeah, we'll definitely come around and do that.
Yep. So thank you everybody for joining us. Hopefully we enjoyed the first version of our tech talk. We'll bring on some more experts and we'll bring up those topics that are kind of important to everybody, and we'll go from there. So thank you for your time and have a great day.
Thanks.